Assalamualaikum warahmatullahi wabarakatuh. My name is NURUL SALWANI binti Cik Murad. I am from DPE 3B. My registration number is 33DPE20F1027. For DGP 30132, Mass and Energy Balance, end of Chapter 3. My group member is DIVENDRA, HAIRI, IKMAL, NURHANNANI and THILAGISHWARAAN. So, today I will present for the question 1 and group 1. The feed contains 8.0 mole percentage propylene, C3H6, 10.0 mole percentage of ammonia, NH3, and 82 mole percent of air. A fractional conversion of 30% of the limiting reactant is achieved. Acrylonitrile C3H3N is produced by the reaction of propylene, ammonia and oxygen. Okay, for C3H6 plus NH3 plus 3/2 O2 equal to C3H3N plus 3H2O. Okay, it's taking 100 mole of feed as a basis. Okay, for the number 1, identity which reactant is limiting and the percentage by which each of the other reactant is in excess. Okay, number 2, discuss all three methods below the 6 moles of product from the reactor. It has 3. A is molecular species balance. Number B is atomic species balance, and C is extent of reaction. Okay, number 3 is describe the mole fraction of the product stream component. Okay, for the solution, question 1. Pertama sekali, C3H6 kita tambah dengan NH3 tambah 3/2O2 akan jadi C3H3N tambah 3H2O. Okay, apabila 8 mol C3H6, 10 mol NH3, 82 mol air akan jadi 0.21 O2 and 0.79 N2. Okay, itu for dia punya, lepas dia punya reaktor tu dia akan jadi N1 dia mol C3H3N, N2 mol C3H6, N3 mol O2, N4 mol NH3, N5 mol N2, and yang last sekali N6 mol H2O. Okay, taking 100 mol of feed. Number of mole of C3H6 sama dengan 8 mol. Number of mole of NH3 sama dengan 10 mol. Number of mole of O2 sama dengan 82 mol kali dengan 0.21 akan dapat jawapan 17.22 mol. And dia punya N2 sama dengan 82 mol kali dengan 0.79 sama dengan 64.78. Okay, thank you.
A very good afternoon to my Mass and Energy Balance lecturers, Dr. Sharifah and Puan Fasiha. My name is Divendra, son of SUBRAMANIAM, with my matrix number of 33DPE20F1022, and I am from DPE 3B. Today I am here to complete my presentation task for this subject, and I will be presenting the slide number 4 and 5, which encompasses how do we find out the limiting reactor and the percentage excess. So I do use the method of applied chemistry. So this is how I use 1 mole of propylene reacts with 3/2 mole of oxygen. So how do I find it is 8 mole of propylene reacts with how many moles of O2. So the O2 here is what we need to find out. So 8 mole of propylene will be times with 3/2 mole of O2. So it will be divided by 1 mole of propylene. So the mole propylene and mole propylene up there will be cutted, and then we will get 12 mole of O2 needed. Whereas it is known as excess because the mole fat is more than mole needed. So the mole fat here is the 17.22 mole O2, whereas the mole whereas the mole of stock needed is 12 mole O2. Thus, we knew from here we knew that the oxygen is excess at here. So the second is we use 1 mole propylene reacts with 1 mole of ammonia. So at the same method I used just now, 8 mole of propylene reacts with how many moles of ammonia. So we don't know the amount of ammonia needed. So 8 mole of propylene times with 1 mole of ammonia divided by 1 mole of propylene. So the mole propylene and mole propylene will be cut off. So 8 mole of ammonia needed. So therefore it is in excess. Therefore it is because the mole fat is more than the mole needed. The mole fat of ammonia here is 10 mole, whereas the mole needed for ammonia to complete this reaction is just 8 mole. So from here we know that the remaining one reactant is the limiting, so which is propylene is the limiting reactant. So here we will be finding the percentage excess of the two excess reactant. So this is how we find it. Percentage excess of ammonia is equals to mole fat minus mole stoichiometry divided by mole stoichiometry times 100%. So the mole fat here is 10 and the mole stoichiometry or mole needed is 8. Divide by 8 and we will be getting 25%. For the percentage excess of oxygen, we will be using the same formula, which is mole fat minus mole stoichiometry or mole needed divided by mole needed times by 100%, which is 17.22 minus 12 divided by 12 times 100%. We will be getting 43.5%. So the other parts will be presented by my friends. Since then, thank you.
Good morning, madam. My name is THILAGISHWARAAN and I am from DPE 3B. My number matrix is 33DPE 20F1033. Today I am going to continue my presentation from the question 2A, which is asking about the molecular species balance. So let us go into this question. For the molecular species balance, it starts from the fractional conversion, which is 0.3 for propene. So in the question, they directly give the propene's fractional conversion, which is 0.3. So the else things is we need to find the N2, which is the outlet of C3H6, which is propene. So it will be done by 0.3 equals to 8 minus N2 over 8, which is the formula for to calculate this fractional conversion, but we are using it to find N2, which is 5.6 mole. After it, we will use the same thing by constructing its equation, which is generation equals to output for C3H3N balance. So the generation is 2.4 mole C3H6 times 1 C3H3N per 1 C3H6. So it is actually times with the stoichiometric coefficient of both C3H3N and the propene, which is C3H6. Then we can find out the N1, which is the output of the C3H6N. So the output of C3H6N will eventually become 2.4 mole. After that, which is the oxygen balance. So for the oxygen, we will, from the given flow chart, we can understand that the input equals to output plus consumption. So the input is 17.22 equals to N3, which is the output of the oxygen, plus 2.4 mole C3H6 times 1.4 mole O2 per 1 mole C3H6. So the 1.5 mole O2 per 1 mole C3H6 is obtained from the stoichiometric coefficient of the equation, the given equation. So the 1.5 is 3 over 2 of the oxygen, which was given in the beginning of this equation. So after multiplying it, we will get 3.6. Then for output, as usual, we need to minus it with subtract it with 17.22. So the N3, which is the output of oxygen, is 13.62. After it, we have to find the NH3 balance. NH3 is also almost similar to the oxygen, because from the flow chart we can find that input equals to output plus consumption. So its input is 10 mole, which is equal to the output of N4, which is still unknown, plus the consumption, which is 2.4 mole C3H6 times 1 NH3 per 1 C3H6. So from this we will find the output of NH3, which is the ammonia, which is 7.6 mole. Next is to find N2 balance and to H2O balance. So to find N2 balance, its equation is input equals to output. It's only involved in input and output. So its input is 82 times 0.79. The 0.79 is because of the nitrogen's actual value, actual fraction in the air, in a normal air, which is 0.79 is for nitrogen and 0.21 for oxygen. So if you plus both of it, we will get 100. So in 100% of air, 0.79 is the nitrogen's fraction. So we need to times 0.79 with 82 mole. So we will get the 64.78 mole of nitrogen. So as N5, which is the output of nitrogen, we can conclude that the 64.78 is the mole found in the output of nitrogen. After that, the last step is for water, which is H2O balance. Water is only generated from the system, so generation equals to output. N6 can be found by multiplying 2.4 mole C3H6, which is propene, with 3 mole H2O for 1 mole C3H6 as per the stoichiometric coefficient of the equation. Then we will find the N6, the output of water, as 7.2 mole H2O. That's it, madam. Thank you.
Assalamualaikum dan selamat sejahtera. Nama saya NURHANNANI HAFIZAH binti JAMALUDDin. Nombor matrik saya ialah 33DPE20F1030 dan saya daripada kelas DPE 3B. Untuk subjek DGP 30132 iaitu Mass Energy Balance, saya akan membentangkan untuk soalan EOC bagi question tu di mana kita perlu mencari atomic species balance bagi setiap komponen produk di dalam reaktor. First, saya akan cari untuk atomic C balance. Seperti yang kita tahu, input adalah sama dengan output. Jadi, pada bahagian ini, kita akan tulis untuk input dan pada bahagian sini kita akan tulis untuk output. So, kita akan buat compositionnya di mana 8 mol C3H6 darab dengan 1 mol C3H6. 8 mol ni kita dapat daripada nilai feed yang dia bagi kat dalam soalan. Darab dengan 1 mol C3H6 per dengan 3 mol C. 3 mol C ni kita dapat dari mana? Daripada C3H6 ni di mana dia ada 3 mol atom carbon. Sama dengan N1. N1 ni kita label sebab kita nak cari nilai feed dia berapa pada bahagian output. Mol C3H3N darab dengan 1 mol C3H3N per dengan 3 mol C tambah dengan N2 mol C3H6 darab dengan 1 mol C3H6 per dengan 3 mol C. So, untuk mudahkan kerja kita, kita boleh potong nilai, boleh potong persamaan macam ini. So, kita boleh mudah untuk calculate. Jadi, okay. So, kita nak cari nilai N1 dengan N2. Tapi kita tak tahu, dia tak ada bagi maklumat. So, dalam soalan dia ada bagi satu maklumat di mana adanya fractional conversion of C3H6 di mana sama dengan 0.3. So, berdasarkan formula fractional conversion di mana mole reactor per mole feed, so kita boleh masukkan nilai ni untuk cari nilai output bagi C3H6 di mana 8 tolak N2 per dengan 8. So kita buat calculation macam biasa, kita akan dapat 2.4 tolak sama dengan 8 tolak N2. So N2 kita akan dapat 5.6 mol C3H6 bagi nilai output. So nilai yang kita dah dapat ni, kita boleh masukkan di dalam equation yang kita dah potong ni. Kita kira, lepas tu kita tulis seperti equation ni di mana dia akan dapat 24 mol C sama dengan N1 3 mol C tambah 3 N2. So nilai N2 kita dah dapat tu kita boleh masukkan di dalam equation ni. So kita akan dapat equation dia seperti 24 mol C sama dengan N1 3 mol C tambah dengan 3 darab 5.6 mol. So kita calculate macam biasa dan N1 kita akan dapat 2.4 mol bagi C3H3N. Okay. Untuk N tu pula ini untuk kita confirmkan betul atau tak kita punya nilai N tu. So kita ambil equation yang sama ni, kita buat tulis balik. Tapi kita masukkan nilai N yang kita dah dapat tadi dalam equation ni. So kita kira macam biasa N tu kita akan dapat sama dengan yang kita kira dekat fractional conversion tu. Okay, bagi atomic O balance pula, kita pada bahagian input dia kita akan tulis 17.22 mol O2 darab dengan 1 mol O2 per dengan 2 mol O. Di mana 2 mol O ni kita dapat dari O2, dia ada 2 mol atom O. Sama dengan 7.2 mol H2O darab dengan 1 mol H2O per dengan 1 mol O tambah dengan N3 mol O2 darab dengan 1 mol O2 per dengan 2 mol O. So kita boleh buat macam tadi, kita boleh potong untuk mudahkan kerja kita. So apabila kita dah potong, kita boleh buat calculation macam biasa. Di mana 17.22 kita akan darab dengan 2, kita akan dapat 34.44 mol O sama dengan 7.2 mol O tambah dengan 2 N3 mol O. So kita buat calculation, kita akan dapat N3 kita nilai dia adalah 13.62 mol bagi O2. Untuk atomic N balance pula, seperti yang kita tahu, N nilai dia adalah gas inert di mana nilai dia akan sama, input akan sama dengan output. So nilai N phi adalah sama dengan output di mana N phi ni sama dengan 0.71 darab dengan 82 yang dia bagi dalam soalan adalah nilai feed dia. So kita akan dapat N5 dia sama dengan 64.78 mol bagi mol nitrogen. Untuk atomic N balance pula, input kita tulis pada bahagian ini adalah bahagian input dan pada bahagian ini ada bahagian output. So kita tulis 10 mol NH3 kita dapat daripada soalan dan dengan 1 mol NH3 per dengan 1 mol N. Mana kita dapat 1 mol N ni sebab dia ada 1 mol atom N. Tambah dengan 64.78 mol N2. 64.78 ni kita dapat daripada yang ini kita dah kira, so kita just masukkan. Itu darab dengan 1 mol N2 per dengan 2 mol N. 2 mol N sebab ada 2 mol atom. Sama dengan N4 sebab kita tahu berapa nilai feed dia. Mol NH3 dengan 1 mol NH3 per dengan 1 mol N tambah dengan 2.4 mol C3H3N darab dengan 1 mol C3H3N per dengan 1 mol N tambah dengan 64.78 mol N2 darab dengan 1 mol N2 per dengan 2 mol N. So kita buat macam biasa, kita potong agak supaya kita tidak confuse. Kita potong mol ini. So apabila kita sudah potong, kita boleh buat calculation macam biasa di mana kita akan dapat 10 mol tambah 129.56 mol N sama dengan N4 mol N tambah dengan 2.4 mol N tambah dengan 129.56 mol N. So kita calculate macam biasa dan dapat akhir kita, untuk N4 kita akan dapat 7.6 mol bagi NH3. Untuk atomic H balance pula, nilai input dan ini adalah nilai output. So kita masukkan nilai dia, kira macam biasa di mana kita tulis compositionnya di mana ada 8 mol C3H6 darab dengan 1 mol C3H6 per dengan 6 mol H. Kenapa ada 6 mol? Sebab dia ada 6 mol atom. Tambah dengan 10 mol NH3 darab dengan 1 mol NH3 per dengan 3 mol H. Sama dengan 2.4 mol C3H3N darab dengan 1 mol C3H3N per dengan 3 mol H tambah dengan 5.6 mol C3H6 darab dengan 1 mol C3H6 per dengan 6 mol H di mana dia ada 6 mol atom H tambah dengan 7.6 mol NH3 darab dengan 1 mol NH3 per dengan 3 mol H tambah dengan N6 mol H2O per dengan 3 mol H2O. Kenapa saya tulis 3 mol? Sebab dekat question dia ada tulis stoichiometric coefficient dia ada 3 pada bahagian depan H2O. So per dengan 6 mol H di mana 3 darab dengan 2 kita akan dapat 6 mol atom H. Kita buat macam biasa, kita potong untuk mudahkan kita kira mol dia. So, kita boleh buat calculation macam biasa. Kita dah potong, okay, kita buat kira macam biasa, kita akan dapat 48 mol H tambah dengan 30 mol H sama dengan 7.2 mol H tambah dengan 33.6 mol H tambah dengan 22.8 mol H tambah dengan 2 and 6 mol H. So, kita kira macam biasa dan nilai, kita tekan kalkulator yang kita akan dapat nilai N6 dia akan dapat 7.2 mol bagi H2O. Okay, sekian. Terima kasih.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad JASNI and my metric number is 3DPE20F1028. Today I want to present about question 2C, external operation. The question is CH6 plus NH3 plus 3 over O2 produce C3CH3N plus TH2O in extent 1. So we conclude mol 1 is equal mol C3H6N in plus extent 1 in equation 1. N2 is equal mol N3H6 in minus extent 1 in equation 2. N3 mol O2 in minus 3 over 2 equation divide equation 1. Divide extent 1 in equation 3. N4 is equal mol NH3 in minus extent 1 is equation 4. N5 is equal mol N2 in equation 5. N6 equal mol H2O in plus 3 divide extent 1 is equation 6. Fractional conversion of C3H6 is equal 0.3 equal 8 plus N2 over 8. 2.4 is equal 8 minus N2, which is N2 is equal 5.6 mol C3H6. Substitute N2 in equation 2, which is N2 is equal mol C3H6 in minus extent 1. 5.6 we got in this equation. 5.6 mol is equal 8 minus extent 1. Extent 1 is equal 2.4. Next, substitute extent 1 in equation 1. N1 is equal mol C3H3N plus extent 1. So the answer N1 is equal 2.4 C3H3N. Substitute extent 1 in equation 3. N3 is equal mol O2 in minus 3 over 2 divide 2.4. So N3 is equal 70.22 minus 3.3 over 2 divide 2.4 is equal 13.62 mol O2. Next, substitute extent 1 in equation 4. N4 is equal mol NH3 in minus extent 1. N4 is 10 over 10 minus 2.4. So the answer for N4 is 7.6 mol NH3. Okay. Substitute extent 1 in equation 5. N5 is equal mol N2 in N5. So 82 minus 70.22. So the answer for N5 is N5 is equal 64.78 mole N2. So for the find the N6 is equal mole H2O in plus 3 divide extend 1. N6 0 plus 3 divided by 2.4. N6 is equal 7.2 mole H2O. So for the N total, we need to plus all the N1 till the N6 that we got in equation, which is the N1 is 2.4 plus N2 5.6 plus N3 13.62 plus N4 7.6 plus N5 6.4 plus N6 7.8 plus 7.2. So the answer for N total is 101 and 2 mole. Okay, for the equation 3, we need to calculate mole fraction of the component. In order to be able to calculate the mole fraction of the component, all we need is divide the number of mole that component by total number and mole present, which is mole fraction yi is equal ni over n total. The n total we just get is 101.2 mole. So the mole fraction is Ya is over mole of A over total mole. So YC3H6 is equal 5.6 mole over 101.2 mole. So the answer is 0.055 or 5.5%. So for the NH3, 1 NH3 is equal 7.5 mole over total mole, which is 101.2 mole. So that we get the answer 0.075 or 7.5%. For the Y oxygen, for YO2 is equal 13.62 mole over total of mole, 101.2 mole. We got the answer for YO2 0.135 or 13.5%. For the YC3H3N is equal 2.4 mole over total mole. We get the answer 0.024 or 24%. So for the H2O, YH2O is equal 7.2 mole over total mole, and the answer of YH2O is 0.071 or 7.1%. For N2, YN2 is equal 64.78 mole over 101.2 mole. So we get the answer 0.64640 or 64%. So for the Y total, we got 0.055 plus 0.075 plus 0.135 plus 0.024 plus 0.071 plus 0.640. So the answer is 1. For the percent, we plus all the percent that we got, so the 100. To calculate the mole fraction, we assume we need to get all the Y total is equal 1 or 100. If we get another value, so it means our equation or our calculation is wrong. Okay, that's all for our group. Thank you.